Question 5 is our probability question. Has Emma going shopping to get her orange juice and her water? And the first part, we've got to fill in this table that's printed on the next page there. And I mean, really, we're just going to say it's a two-way table adding things up. So we must have 0.35 here, because those two add together to make 1. We must have 0.7 here, because those two add together to make 1. Going down the side here, we're going to need 0.55 there, because those two add together to make 0.7. 0.2 here, adding across, 0.1 here, adding across, and checking all the ways that it all adds up. What you must make sure you don't do here is do any timesing to give those things here. Because these things aren't independent, you can't times them together to give that answer. In fact, that comes up later on. Part B says, hence or otherwise find which is going to buy orange juice or water, but not both. Well, here's her buying orange juice, but not water. And here's her buying water, but not orange juice. Add those two together, and we're going to get 0.25, but not both, not that one there. Now, they're not mutually exclusive, because they can happen at the same time, because the probability of juice and water equals 0.55, and that doesn't equal 0. If they were mutually exclusive, it would have to equal 0. And they're not independent either, because the probability of juice times the probability of water is actually 0.65 times by 0.15, and 0.65 times by 0.15, I think I worked it out earlier. That's why I marked it up, not 0.15, sorry. 0.65 times by 0.7. 0.65 times by 0.7 is 0.437. And this is not the same as the probability of the juice and water that we've got here, which was 0.55. Sorry about that. But those two are different. The fact is you can't multiply that and that together to get that. It doesn't work. So the other way of doing it would be to say, well, what is the probability of water? The probability of water, of course, was 0.65. And let's try again then. What's the probability of water given juice? The probability of water given juice is that out of juice 0.7, and that divided by that again doesn't equal the same thing. They don't match. Lots of different calculations to show that they're not independent. Part B then, Reese is off shopping now and he's got 3 things to get, but he sometimes gets them, sometimes doesn't. Let's go for none of the 3 items. Well, if we don't want any things, we don't want milk, we don't want cheese, and we don't want yogurt. Well, not wanting milk is 0.15, just the opposite of that. No cheese is 0.4, the opposite of that. And no yogurt is 0.45, the opposite of that. Times all those things together, and you get 0.027. Bit more work now about 2 of the 3. And so now, first of all, think, well, what 2 could you get? So we could get milk, cheese, but not yogurt. We could get milk, yogurt, but not cheese. We could get cheese, yogurt, but not milk. And now just stick those into figures. So milk, cheese, but no yogurt. Milk, no cheese, but he does get yogurt. And here we've got no milk, but he does get cheese, and he does get yogurt. Times all of those together and add them all up to get the right answer.